All right, 11.3, just called data or data distributions. This is going to be a little more mathy, not intense like stuff you've dealt with before, but you just have to understand, again, the definitions and what the definitions mean and what they're asking for, so you kind of know what to hunt for. So here we go. Example 1, find the measure of the center and spread. What the heck is that? Well, starts out with a definition, the mean, and you guys, I'm sure you've heard this before, but the mean means the average of all values in the data set. So my mind goes to basketball, and you know, a certain basketball player if that was 3 nights, but so definition, we'll put it to practice in a second. Standard deviation is going to be hanging around, so you need to really be comfortable with it from the average. And we're going to work with this, so hang in there. So first of all, they just want you to warm up. What is the average of the following data set? Well, if you know just simple rules on how to find the average or the mean, you add each of these values up. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. So I'm adding them all up, showing my work, divide by 15, and then my average or my mean is 12. Now when you got a big old list like this, you might want to, like, when you're typing in your calculator, cross them off, cross them off. It's very easy to forget one of these values. We just don't concentrate very well, so it's easy to make a silly mistake. Next question says, what is the 5-number summary? Big time quiz question, test question, because it makes you do a lot of little different math. Of the data set, they're talking about this data set right up here. So what are the 5 parts? Well, what's the minimum? What's the maximum? Those are easy. First quartile, what the heck is that? Median, what's that? Third quartile, what's that? Well, believe it or not, these 3 things all have to do with the median. So if you're driving down an expressway and you talk about the median, kind of self-explanatory, it's the grassy area in the middle. So we'll talk about that. And we'll talk about first quartile, third quartile. Let's just get going. So to do this, to answer all of these questions, you must rearrange that entire number set in ascending, lowest to highest order. So I've done it. So this is another time where you got to be very careful. I put the 3 first. I'd want to cross the 3 out. I put a 4. I cross the 4 out, just so you make sure you have every piece of information here, or else it's just going to be a nightmare for you. So there, I've put it in ascending order, lowest to highest. And now here it comes. The minimum, pretty easy. What's the smallest? 3. It's right there. Maximum, very easy. Highest, 25. Do you have to rearrange it to figure that out? No, but it's going to be very important to find the first quartile, median, and third quartile, so you have to do it anyways. So minimum, maximum, there they are, cha-ching. Now what's the median? Well, the median, I said, is middle. So it's really easy if there's an odd number of values. So look, we got 1, 2, 3, 4, 5 items in our data set. That means the middle would be the third, and our answer would be 7. But if you look at this, we got 1, 2, 3, 4, 5, 6, 7, 8. Hold on a second. Timeout. All right, I don't want to confuse you, but I did notice something. This says, what is the mean of the following data set? There's nothing wrong here, but I think whoever made this packet might have messed up a little bit, because there was supposed to be another 6 in this list. So what I'm going to do is I'm going to just say the answer to this is correct, because there are 15 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 items. That's why I divide by 15. This list, and I just copied this from the book, actually has an additional 6. Notice this only has 1 6 in the whole list. And then for this problem, they threw in an additional 6, which means there are 16 values here. And so, with that in mind, so I go back to this. It's easy if there's an odd number of values to find the median. There's 5 values, so I take the third one, it's a 7. This has 16 in it. So what I've done is I've taken the first 8, 1, 2, 3, 4, 5, 6, 7, 8, which takes me to right here. And then the next 8, 1, 2, 3, 4, 5, 6, 7, 8 are right here. So we've got 8 and 8, a total of 16 values. I got a little thrown because this list had 15, and I thought they were using this list for this problem, but there's an additional 6. So I hope you didn't get lost there. So here's the thing. We're trying to find the median of this list. Well, there's 8 here and there's 8 here, so there's really no middle in an even number of things. So what you do is you take this value and you take that value and you find the average. So you add this to this, divide by 2, or you just use common sense. That'd be 12.5 would be the median for this list. This is easy. This takes a little bit of math to find the middle. So there you go. It's 12.5. Now, let's keep going. How do you find the first quartile, and how do you find the third quartile? Now notice, we found the min, that's one thing. The max, that's another thing. We found the median, that's another thing, that's 3. They're asking us to find 5 things. The last 2 things are the first quartile and the third quartile, and it's pretty simple, it just sounds hard. So the first quartile is the median of the lower half values, so it's the median of this list. And the third quartile is the median, or the middle, of the upper half of the values, so this half. So what do? Well, because there's 1, 2, 3, 4, 5, 6, 7, 8, we got to go 4 here, and 4 here, 4 here, 4 here. What's in the middle of 6 and 6? Well, that would just be 6. The average of 6 and 6 is 6, if you want to look at it that way. This one's going to be a little different. We take off the first half, we take off the second half of the upper half of the numbers, hence the third quartile, and then we've got a 15 and a 16. Well, what's in the middle of those? That'd be 15.5. All right, so the next chunk, example 2, is talking about being skewed left, symmetric, or skewed right. We're going to talk about this in a minute, but we're going to add some definitions and then talk about this. All right, so pay attention to this. Here's some definitions. Skewed distribution is data that creates a shape where the shape is unbalanced in the positive or negative direction. So negative direction is left, positive direction is right. You can kind of see that this is symmetric, which is the opposite of skewed. Skewed is when reflected over the mean. So the mean is the middle number. You've got balance on this side and that side. You can see it's reflected. This side is a lot like that side, roughly the same. So pay attention to that. It doesn't need to be perfect. This example's perfect. Doesn't have to be. It's roughly the same. But clearly this and this over the median or mean, actually I should have said mean, sorry about that. Over the mean, this side does not reflect this side at all. Now, when I first learned this, I thought this is backwards looking, because skewed left, I was looking at the peak, and the peak's to the right. This is talking about where it gets flat. It flattens out on the left, so it's skewed left. This flattens out on the right, so it's skewed to the right. That's where it flattens out. So that's the key to this thing. Where does it flatten? Don't look for the peak, because you're going to say it's skewed left. Look for it where it flattens out. This is where it's skewed. The information is skewed here, and it's skewed here. All right, new definitions. All right, so next question. It says, what measures of center and spread would you use for the following data set? So there's the question. Let me do some work. Be right back. Okay, so you're going to create your own grid here. It says on the left-hand side, frequency. That just means the number of times a certain number shows up. So here's your values, 0 to 5. And notice this is already in ascending order for you. So if it wasn't in ascending order, you might want to do that. Put it in ascending order. If you wing it, there's danger in that. So there it is, ascending order. So how many values between 0 and 5? Well, there's none. How many between 5 and 10? Well, and I'm kind of including 10 in this space. There'd be 1, so I'll make a little chart here. How many numbers between 10 and 15? Well, if we take a look, I see the 13, so I know there's 1 in there as well. And then between 15 and 20, I see 1 again, the 16. Now we're just climbing up. So between 20 and 25, there's 2. So I'm going to jump up just a smidge, and there's 2. Between 25 and 30, so 1, 2, 3, 4. So that jumps up to 4. Now between 30 and 35, 1, 2, 3, 4, 5. So that jumps up a bit more. Then between 35 and 40, I've already counted the 35 in here. So anything between 35 and 40, like 36 to 40 is just 1. So that drops back down to 1. So there's my drawing, and we're going to talk about it. All right, so nickel and dime. This question's kind of vague. It says, what measures of center and spread would you use for the following data set? In other words, be prepared to answer all of these questions. Is it skewed left or right? What's the median? First quartile, third quartile? What's the range? That's new. What's the interquartile range? That's also new. Now, I know it can be overwhelming, but let's just nickel and dime this. Is this skewed left or right? Well, because it goes like this and like this, it's skewed left. All right, so what's the median? Well, don't forget, the median is the middle. So we're going to count. Look at all our pieces of information here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's odd. So what we're going to do is count 7 on one side, 7 on the other side, and the one guy in the middle is going to be our median. So 1, 2, 3, 4, 5, 6, 7. And there's the guy in the middle, 1, 2, 3, 4, 5, 6, 7. So our median is 29. Super easy when there's an odd number of items in your data set. So, good time to get out some colors here. So this right here is your lower half of your data set. This is your upper half. And to find the first quartile, we're going to find the median of the yellow stuff. Well, we got 1, 2, 3, 4, 5, 6, 7 things there. That's convenient. So I'm going to take the middle of that guy. That's 21. Same thing here. 1, 2, 3, 4, 5, 6, 7. I'm going to take the middle one, which is that guy, and that's 33. So we found our third quartile in our upper half of our data set. I know it's a lot of language, but the math really isn't that hard. Now the range is super easy. It just takes your highest number and you subtract your lowest number. So that's just 37 minus 10, which is 27. Now we're going to talk about this in a second, but let me get set for that. All right, what I was going to do is unnecessary. The interquartile range, just stick with the program. What'd you do? You took the highest number of the whole set for range and you subtracted the lowest number. Well, the interquartile range is very similar. You take this guy and then you subtract that guy. And that gives us an interquartile range of 12. Now the deep concept here is you're trying to figure out how nice and neat and tight your information is. There's more of this coming, but right now you're just kind of learning definitions and finding answers. But what good is this? Well, that stuff's coming. Be patient. Okay, so this next little section, recognizing a normal distribution. So you have to know what a normal distribution is and what a normal distribution isn't. So the first thing we're going to tackle is this right here, the heights of, well, first of all, what is a normal distribution? We'll get that defined. We'll talk about this, the heights of all the people in a large group, the probability of landing on each of 8 equal parts of a spinner, scores on an easy test, the number of children in a family. So you can definitely see some differences in these graphs, and there's a definition of what's normal and what's not. So here we go. Okay, so normal distribution, here's the definition. When you're done plotting or graphing the information, it's symmetric, which means mirror images about the mean. So this would be the mean right here, ish, and it's called a bell-shaped curve. Get to know that. If it's a bell, the shape of a bell, that's considered normal distribution of data. So it says the heights of all people in a large group. So if you took the heights of our entire high school, that would result in a bell-shaped curve. So this is considered normal distribution. Look for the bell-shaped curve. That's normal. That's kind of what everything's based on. Well, is this a bell shape? No. Is this a bell shape? Well, we can talk about that. And then is that? No. But this is the probability of landing on each of the 8 equal parts of a spinner. So somebody spun the spinner a bunch of times. This is the times it showed up as a 1, around 15 or 16. 2 was around 12 or 13. 3 was the lowest, kind of like old blue sometimes, like 6 or 7 times, and etc., etc. So this is not normal. No bell-shaped curve. All right, so this might throw you a little bit because you're like, it kind of looks like that. But notice the mean is right here. And it looks skewed left. And remember, this is the key word, easy test. That means there's going to be a lot more people getting good scores. They say a perfectly written test is going to look like that. And this is not. This is an easy test. We got a lot more people doing well than not doing well. So this is close to this, but this is also not normal. And then the number of children in a family, clearly, there we go, the Schwantz. We're out here, very few people have that many children. Go Schwantz. But anyways, you see this nowhere near the bell-shaped curve, so this is not considered normal distribution. So don't get this confused. It's normal, but it's not normal distribution. So be careful with the wording there. This is considered normal distribution. The data is distributed evenly. There's a peak in the middle, and then it goes like that. So that's the key to this information. And this is skewed to the right. I forgot to say it, I think, but I want to throw that in there. And this would be slightly skewed to the left. This is not skewed, this is just all over the place, kind of random. All right, this video is a little bit longer, but I'll try to get her done. Classifying a data distribution. It says, how would you classify the following data set? Describe the shape of the distribution and the center and the spread of the data. A lot of information, but let's just follow through here, and you'll have a chance to practice this on your homework, so don't panic. So here we go. Okay, so what have I done? Notice 64, crossed it off. 72, crossed it off. And I just kept going, because step one, we're going to write all of this in ascending order in order to do all that they're asking us to do. You'll get used to this and what it means after you practice it a few times. Second thing we're going to try to do, after we've written it all in ascending order, and I double-checked and I counted all the pieces of information, and it matched. That's something I do, OCD or wisdom, I don't know. Make a histogram. Now that's kind of challenging when you first start, because you're wondering, should I make my histogram? And again, what is a histogram? Well, we made one right here, and we did it in chunks of 5, and it just makes sense because you can kind of see the number of, well, the spread of the numbers from 10 to 37. You know, it's 27 between, so chunks of 5, it just kind of fits. This looks a little different. The numbers are more spread open, spread wide, 120 and 64, that's 60, so I'm going to go chunks of 10, just so I don't have to take up this whole page here, and I'll be right back. So, experiment a little bit. I know that 64 is my smallest number, so I started chunks of 10, and I started with 55, knowing that if I got up to here, it's just kind of experimental, chunks of 10, and I went lower than that, and then I started with 55. So that'll be a little confusing, you know, where to start these numbers, but you'll kind of get a grip for it. Chunks of 5, chunks of 10, starting with 5s or 0s, you'll kind of get a knack for it. So numbers between 55 and 65, there's 1. So we're going to start here, because 64 fits right in there. Between 65 and 75, well, there's 1. Between 75 and 85, 2. So we're going to jump up to 2. From 85 to 95, 1. Back down to 1. 95 to 105. That would be 1, 2, 3, 4. So that jumps up quite a bit. 105 to 115. That would be 1, 2, 3. I'm going to count it in this chunk. 115 to 119, or 115 to 125 would be the rest. So that'd be 3. So that would also drop down to here. Okay, so we've made that histogram. Now we can start making some choices. So they might ask you, is this symmetric, skewed left, or skewed right? Because it has a tail that goes this way, and the peak is over to the right here, this would be called skewed left. They might ask for that. All right, so center and spread, find the median. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 items. And so that means, again, 7 to the left, 7 to the right, the 1 in the middle is what we're looking for. So 1, 2, 3, 4, 5, 6, 7. There's my third quartile. There's my first quartile. So there's my median. Now my first quartile is the median of this information. 1, 2, 3, 4, 5, 6, 7. So I need to go 3 in this way. The fourth one is going to be 76. Third quartile. 1, 2, 3, 4, 5, 6, 7. So I go 3 back or 3 up. Whatever's in the middle is my third quartile. Now what's the range? Well, 120 minus 64, which would be 56. The interquartile range would be the upper third quartile minus the first. And that's 24, it's 39. So So there's your center and spread. That does it. Good luck on your homework.